In this problem, we're going to solve this antiderivative by using partial fraction decomposition. Now, we already have the denominator factored into one linear factor and one irreducible quadratic factor. So the way this one is going to be set up is we're going to be looking at an antiderivative of the form a over x minus 4. Because it's a linear factor, it only gets an a, plus, now we have a irreducible quadratic factor for the second part, x squared plus 36, which means we have to account for the fact that the numerator might be linear. So bx plus c dx. So there's the form that our result will be in. Now, what we need to do is multiply our new constants by whatever's needed to get a common denominator. This is the least common denominator here. So a would need to get multiplied by x squared plus 36. bx plus c, on the other hand, already has that in the denominator, so it would only need to get multiplied by x minus 4. And we would like that to be equal to our numerator, negative 9x squared plus 17x plus 32. Now, what we need to do is multiply this left-hand side out. So we'll distribute the a. So we get ax squared plus 36a. And the second part we'll do is foiling. So we get a bx squared plus cx minus 4bx minus 4c. Again, all equal to that left-hand side. Now there's a couple different ways we can go about this next part, but the bottom line is we have to set up a system of equations to solve. The way I like to do it is I like to keep my equations grouped by which term of x there are. So x squared, x to the first, and my constant of x to the 0. Now I'll show you how I collect these. First I look for anything with an x squared in it. So I have an ax squared, so a bx squared, so a plus b. Now what does that have to equal? Well, in order to equal this left-hand side, they must be equal to negative 9. That's our first equation. Now we're going to do the same thing for x terms. There's not many x terms here, so we have positive c minus 4b equals 17. Notice I don't put the x's in. They're represented over here. I'm just looking to solve these coefficients, and I'll show you how we can do that with a matrix once we have it set up. Last, we have our constant terms. So we have 36a minus 4c, and that has to be equal to our constant term of 32. Alright, so let's see how we can set up a matrix and solve that matrix. So, if we were to set up a matrix, we'd have 1, 1, 0, negative 9. Here there's no a, b is negative 4, c is 1, the solution is 17. And finally, we have 36, no b, a negative 4, and a 32. So there is our augmented matrix. And I'm going to show you real quick how that can be calculated with a graphing calculator. So a little bonus here. So first thing we have to do is enter this in as a matrix. A 3 by 4 will work perfect. So if you go to matrix, and I'm going to edit my 3 by 4. I'm just going to overwrite what I have in here. So 1, 1, 0, negative 9. 0, negative 4, 1, and 17. 36, 0, negative 4, and 32. I now have my matrix in there. I'm going to quit out of this. If I check, my matrix is exactly what I have here. Now what I want to do is put this in what's called row reduced echelon form. So I go back to matrix. Now we're performing math. Scroll down to RREF. And I'm going to do it with matrix A. So matrix names A. Calculate. Now what I'd like to do is have this in fractions. So math fraction, and there's my answers in fractions, A, B, C. So I know A has to equal negative 11 over 13. B has to equal negative 106 over 13. C has to equal negative 203 over 13. So these are the constants that are going to make this problem work. Now let's see if we can fit the rest of this problem off to the side. Now we have A and B. So we know that we are trying to solve the integral of negative 11 over 13 over x minus 4 plus negative 106 over 13x minus 203 over 13 all over x squared plus 36. So there's the messy integral we're trying to solve. So let's put this on another sheet for a little bit more room. So what do we have? And I'm going to pull out the constants to make it a little bit easier. So negative 11 over 13 times the integral of 1 over x minus 4 dx. And we are missing dx's here. Now, what I'm going to do in this second integral is I'm going to split it up into two integrals to make it easier to deal with. So the first one, and I'm going to pull out the constant, so plus a negative 106 over 13 times the integral of x over x squared plus 36 dx plus a negative 203 over 13 times the integral of 1 over x squared plus 36 dx. The constants are messy, but these integrals are not bad. This first one, we have negative 11 over 13 ln of the absolute value of x minus 4. This next one will be a u sub. We're going to let u equal the denominator, x squared plus 36. So du is just 2x dx. So if I put a 2x in here, I will multiply by a 1/2 out here for my substitution. And that is going to give me a negative 53 over 13 times the integral of du over u, which is just an ln of u. So this is minus 53 over 13 times the natural log. Now this time we don't need absolute value because the u was just x squared plus 36. So we can use parentheses. And lastly, I have the minus 203 over 13. If you don't recognize this, this is actually an arctan. What we're going to need to do, because there's a 36 here, we need to put a 1 over the square root of 36 out front. So 1 over 6 arctan of x over the square root of 36. My apologies. That should be the square root of 36, which is 6, with a plus c. Got a little bit of simplifying we can do there. So our answer is negative 11/13 natural log of the absolute value of x minus 4 minus 53 over 13 ln of x squared plus 36 minus 203 over 84 arctan of x over 6 plus c. Not the prettiest antiderivative we've ever seen, but we were able to find it.